Bienvenidos nuevamente a Infeal, su compañía especializada en soluciones innovadoras para Green Data Center. Recuerden que contamos con cobertura nacional para atender sus requerimientos. Hoy vamos a tener una conferencia con el ingeniero Don Beaty, fundador de la TC 9.9 de ASRA especializada en Data Center. Espero que la disfruten y aprendan mucho. Muchas gracias.
So now we go ahead and we look at this overall region, and it shows you in ash rate terms, we use bin hours, the total number of hours per year in any given bin, any given grouping, so to speak. And it shows that typically in this region, it might be 68% of the time. It would be in that 15 to 20 degrees C, and then 20 to 25 this, and on down the line. If we look at the recommended versus A1 through A4, we see a vast amount of the time, that we can operate in the recommended range. Now, this depends on the elevation that you're at, right, and diurnal temperatures and all kinds of different things. So now here's a plot. Oop, I got the wrong one. I got Panama in here. Sorry about that. But anyway, you do a plot here to go ahead and show what it is within a given region for the amount of bin hours in order to go ahead and figure out what that means. Now, this next thing is anti-intuitive. It turns out that the IT manufacturers, they make their money. They make their money by not over-designing. If they design perfect equipment, they don't get enough sales. That's true of any manufacturer. So what do? What they do is they manage to the return rate, the amount of return due to defects. They monitor that, and they have their own business rules as relates to what the right percentage is to get the most profit and yet the best reputation. So for years, many, many years, each manufacturer on the committee and not, IBM, Dell, HP, Cisco, all those manufacturers monitored their failure rate. They never told us what it was. It was a competitive edge. Based on the pressure to save energy, we ultimately got them to disclose the failure rates. So they've disclosed the failure rates, and so what it shows you is what you would think, but the conclusion is the opposite of what you think. What it shows is colder is better. Colder is better. So we got them all in a closed room, nobody there but the manufacturers, so that they would be more open, and they went ahead and they discussed their failure rates. And they agreed, so they probably diluted the failure rates amongst their competitors, and then they diluted it more when they gave it to us. This is very conservative. So we have published failure rates, and the failure rates are historical. This is not theoretical information. It's historical, and that's great. And so what it says is taking a baseline of 20 degrees C, 20 degrees C. So we take 20 degrees C right here, baseline is 1 for failures. 15 degrees C, it says 0.72, 28% less failures. It goes ahead and says 40 degrees C, 66% more failures. This is not feeling very good to us. However, it turns out that the average failure rate in the industry across the world is 2 to 4%, average failure rate. So to exaggerate the problem, I picked the higher number, 4% failure rate. So now if we apply this 0.72 times that 4% failure rate, it means that the failures by operating at 15 degrees C rather than 20, instead of 4%, it becomes 3%. It's not perfect. It's just a 1% difference. And therefore, if we go and we look at 40 degrees C and 1.66, even at 40, it's only a 3%. 3% more failures across the base of 100% of the servers. So really an interesting thing. Then, when you tie this into ASHRAE bin hours, it's all according to how many hours there are that would be 40 degrees C. Is it always 40 degrees C here? It isn't. And so those all enter into it. So now we go ahead, and this gives you the full range here. You can see that you can look at it at your leisure. I will, when I get back to my office, I will send the presentation. And so now we go ahead and we look. And we look at a weighted average of Bogota, and 92% is in this kind of range for based on ASHRAE published information for an average year, not a maximum year, an average year. That's all. And so you can adjust it however you want, but it fundamentally can end up with a failure rate, even using an economizer, of less than the baseline of operating at 20 degrees C full time. And this kind of shows different parts of the world, and here's that failure rate of 1, and it shows some of them being above and some of them being below, and so it's an interesting kind of analysis. Now, everything we do today is about baseline. So you could argue that ASHRAE TC 9.9, that we are significant failures. Significant failures because we said that you could easily run 18 to 27 degrees C, yet how many data centers run at 27 degrees C? Just the internet data centers, some of them. The rest do not. But if we go with the baseline of pre-2004, where it was 18 degrees C, here's a survey from Gardner in 2012, and it shows the percentage of people at different temperatures. And we see here that a reasonable amount are now above that 18 and are really at that 22, 23, 24%. So on the baseline of the 18 degrees, we see a rather significant increase. If we look at the baseline of 27, we do not. So it's all about baseline. Now, this slide, what is this slide showing? It is showing that all we care about is the inlet to the rack, the inlet temperature, and then the exhaust temperature. Now, it turns out that let's say we run, I don't care what the temperature is, let's make this be 25 degrees. It turns out at the component level, at the processor level, the junction temperature is 85 to 105 degrees C. Because of other things, mainly the rear of the rack, which is right here, the rear of the rack, because of the issues of cabling, the manufacturers limit the discharge temperature to 58 to 60 degrees C.